Hello everyone and welcome back to the State of the Web. My guest today is Adi Osmani. He's an engineering manager on the Chrome team focusing on web performance. And today's episode is all about JavaScript. It makes the web go round, but too much of it can actually be a bad thing. This is the state of JavaScript. Let's get started. Adi, thanks so much for being here.
Thank you for having me.
So how long have you been doing web development?
Whoa, way too long. It's been about 17 years now.
And I understand that you used to build your own browser. Is that true?
Yeah, instead of learning web development, I decided to build a browser to understand how browsers work. So I built something that supported HTML parsing and CSS, and my path to JavaScript was building a very small engine for understanding how it worked.
So back then, what was the state of JavaScript like? Was it just being used as a toy for DHTML?
JavaScript was being used for adding rainbows and sparkles to your web pages. It wasn't being used to build really complex apps. And that's kind of where we're at right now. In the post-Gmail era, we're building entirely complex applications, sending more and more JavaScript out to our users.
So how do developers know if they have a JavaScript problem?
So building interactive experiences on the web today usually involves sending JavaScript out to users, often too much of it. And the impact that can have on the experience is that if you're sending too much JavaScript down, that involves a CPU having to spend a lot of time processing it. It can take a very long time on mobile devices. If you're on a slower network, that can also mean it will take a while for that JavaScript to be downloaded. The way I like to think about measuring if JavaScript is a problem for your site is using a workflow that is measure, optimize, and monitor. So for measuring if JavaScript's a problem, I recommend folks check out Lighthouse. We've got a number of performance audits in place there. So go run Lighthouse from the Chrome developer tools. It's also supported on web page test. And that'll give you some insight into, are you just sending way too much code down to your users? If you are, it'll tell you if JavaScript boot up time is an issue. And it'll also give you a few ideas around things that you can do to reduce that amount of script. Now, the reason why JavaScript has got such a cost is that there are a number of different steps a browser has to take in order to process it. If you're loading up a web page, that JavaScript first of all needs to be fetched over a network. It then needs to be parsed by the browser. Parsing can take a very long time on a slower CPU. It has to be compiled and then executed. For many sites, if you're shipping megs and mountains worth of JavaScript down to your users, that can take seconds and seconds of time.
And that's not so uncommon. In the HTTP archive, we've seen at the 90th percentile, sites are actually sending more than a megabyte of JavaScript. And that's gzipped and minified.
Yeah.
So that's a lot of code.
That's a lot of code. That's as you said, that's minified and gzipped code. We're saying, uncompressed is probably 2 or 3 times that. So a lot of people are, having a browser deal with megs of JavaScript, literally, that has to process. Which isn't great.
Yeah, but the good news is that the median is only 400 kilobytes. It's still a huge amount of code, but it's not in the megabytes, luckily. Yeah. So what guidance would you give to developers to use JavaScript responsibly?
Throw it all out. No, don't throw it all out.
That.
You can't throw it at all. So what I recommend doing is only ship the code that your user needs for the current page or the current route. Very often, what sites will do is they'll bundle all of their JavaScript into one big monolithic blob, and they'll ship that down. Instead of doing that, what if you broke it up in smaller pieces? So just ship the code needed for the current page. Once that's fetched, you can use techniques like prefetching, pre-caching, using a service worker to go and start fetching in, lazily loading in the rest of the code needed. And the benefit of that is that the user can start interacting with the experience very early on. If they go and start interacting with the rest of the pages on the site, you've had an opportunity to get that code into the cache and maybe it'll load a little bit quicker. So in general, try to do that. The technique that you'd use for that is called code splitting. It's a technique supported by lots of tools, things like Webpack and Parcel support it. It's possible to code split using things like React and Vue and AngularJS, Preact. Most popular frameworks support this. I would love to get to a point where more frameworks are code splitting by default, or rather just encouraging you to kind of shape your code so you're not going to be bundling everything into a single file. But code splitting is the first big one. I think another thing you can do is take advantage of techniques like tree shaking. So tree shaking, although it sounds a little violent, is this idea of removing unused imports in your code. So if I'm going to be importing in a library, like some piece of UI, maybe I'm importing in Bootstrap, or I'm importing in something else, I probably don't need everything that it provides. So tree shaking is this idea of only including the imports that you're actually using and stripping away everything else to reduce that overall amount of script in the experience. There are lots of other things we notice, like most of the sites that I trace will include polyfills that are probably not needed for modern browsers. A common one is people still polyfill JavaScript promises. Promises have been well supported for a number of years, I promise. But I think that audit the polyfills you're stripping down. Check on the weight of the libraries you're importing. One thing folks can do is use tools like Source Map Explorer or Webpack Bundle Analyzer. And what that'll do is it'll give you this really pretty big graph showing you, okay, well, here's your application logic. Here are all the libraries that you're importing. And by the way, maybe it'll highlight opportunities to remove duplicate code, because sometimes we'll import things multiple times by accident. Or opportunities just to swap out the libraries we're using for much smaller ones. A popular example is if you're building an app that's working with dates in any way, people will use Moment.js and the Moment.js locales. Those have a heavy weight to them. It's a couple of hundred kilobytes. You could switch that out for something like date.fns. It's much smaller, still has the same capabilities for the most part. But keep an eye on the cost of your script, because there are usually a few things you can do to bring that size down.
So I have to ask, what is the state of third parties in JavaScript? Maybe ads and the like?
Third parties are an interesting one. So third parties have got this reputation, and well-earned so, of tanking web experiences quite often. And this is particularly a problem with publisher sites, news sites. I would say that we often see a lot of first-party code still having a big issue. So as we increasingly start building experiences using JavaScript, there's going to be a balance of first-party code being a big issue, third-party code being a big issue. For third-party code, it's really important to, first of all, again, audit the impact of those experiences. There is a chance that maybe your site is using an ad network of some sort. Maybe you don't have as much control for the type of content they're going to pull in. What I would do there is just take a look at whether there are options for you to lazy load some of those frames, some of those embeds, so that the users are not paying for the cost of them when they're just loading up the site. We are exploring a few ideas in Chrome at the moment to try helping with this. Things like adding support for lazy loading to the platform for images and iframes. I'm hopeful that will help. I'm hopeful that future ideas like feature policy, where you can sort of control what a third party can do, will also help a little bit here. But in general, just try to audit those third parties as much as possible and check if they actually are providing value to the site. In the case that you're trying to nail down, okay, well, what specific third party is responsible for a lot of script? The Chrome DevTools actually have support for this feature called third-party badging. So if you go and record a new profile using the performance panel, open up the page, take a look at your trace, what it will say is these are all of the different sort of brands or companies who have loaded up third-party script in your site. You can then go and organize it sort of bottom up or via different ways of visualizing the data and see, okay, well, who has actually been spending a lot of time in script, and figure out, are there ways for me to send feedback back to those ad providers, or options for me to evaluate if I could switch out my providers to somebody else that isn't going to tank performance quite as much.
So assuming a developer can improve their JavaScript and their web performance, how can they ensure that they can stay fast? Because regressions happen, requirements are changing. The more they touch their code, the less likely it is that it's going to stay fast.
Yeah, absolutely. I think as an industry, we need to shift towards adopting performance budgets. Something that I commonly see is, an engineering team will get really psyched about improving their performance. They'll do a sprint where they try to make things better, and they'll celebrate those wins, come back a quarter later, and suddenly everything is on fire. And the reason for that is often that we're not enforcing budgets for, how well we are agreeing as an organization that the experience has to be. We need to get to a place where, like, sites have agreed on, maybe not shipping more than 170 kilobytes of minified and gzipped JavaScript for their experiences, or whatever number makes sense to keep your time to interactive, in a good place. But once you have those budgets in place, it can be enforced at a continuous integration level. So, if I'm an engineer working on a new feature, and I submit that to my team, hopefully, in Travis or something else, they'll be able to see in the pull request, okay, well, the cost of this feature was so-and-so, and it has or hasn't broken the budget. And if it has broken the budget, I think that that's an opportunity to empower sort of project managers to make a call on, is this feature we're adding actually worth it to the impact it's going to have on the performance of the site and the user experience. I feel like today maybe we aren't giving PMs quite as much data needed to make those types of calls. So there's an amount of work we need to do on the engineering side, on the PM side. I also think that we need to do an amount of work to get just businesses to understand the value of adopting performance cultures and keeping those budgets in place. Because as you mentioned, like, regression analysis is something that's kind of, it's missing right now. We do a lot more there. For folks that want to adopt performance budgets for their sites, I'm happy to recommend checking out Lighthouse CI. Also happy to recommend checking out Speed Curve or Caliber. These are third-party solutions, but they have support for setting performance budgets based on sort of a metrics level or a size level. And they'll give you sort of alerting capabilities as well. So if your team happened to work on new features and they break your JavaScript budget, you can start getting alerts in the middle of the night saying, hey, fix it, which is slightly better than the situation we've got today.
Are there any changes browser vendors could do on, like, the web dev tooling side?
Yes, absolutely. So it's a really tricky problem to solve, right? Because a browser isn't just going to completely disable JavaScript for everybody. That would break a lot of the web. What we can do is take into account, different heuristics. So if you are on, say, a effectively slow 2G network, and we don't think that there's a chance you would have otherwise been able to view any content, one of the sort of interventions we're exploring is this idea of disabling JavaScript, at least for a preview of the experience. So maybe we just show you, initially the site without JavaScript, allow you to see some content, make a call on, is this actually the thing I was looking for? And if you want, we'll show you like a little info bar at the very bottom of the screen, so you can view the original site and the original content if you'd like, but hoping to give people a slightly better user experience at the end of the day. Now, these types of interventions are something we're very careful about. We're trying to make sure that as much as possible, it's only going to be explored for sites that we know are probably going to be able to function without that much JavaScript in place. But we're exploring some ideas. I think there's definitely a lot more that browsers can do in this space.
Well, Addy, thank you so much for being here. I'm going to go check out your browser and compare benchmarks on JavaScript to see how that compares to Chrome today.
The answer is it's going to be awful, but measure the cost of your JavaScript and try to figure out if it's a problem for your users.
So we're going to have links to everything we talked about in the description: Lighthouse, web page test. Click on those, measure your JavaScript, and stay fast. Thanks for watching. See you next time.